Hi, and welcome back to Allen High School's PreAP chemistry discussion of solutions. And we're moving into a discussion on solubility. I've already done this chart at the top. That would be the previous video. We're starting down here. Now, solubility refers to the maximum, so that's the word that goes here. I like to use the symbol S, especially when we get into AP chemistry. Refers to the maximum amount of a solute that dissolves. And note we have to specify two things. The first thing we have to specify is the amount of solvent that it's being dissolved in. So for example, if I asked you what the solubility of sugar is in water, or in your iced tea, well, it would depend upon whether you got a 16-ounce iced tea or whether you got a big gulp iced tea. It depends on the amount of solvent. So we're going to be seeing values that are going to somehow have a per solvent component, per amount of solvent. Now, the other important component is that it's at a specified temperature. And if it's a gas, we also have to specify pressure. We're talking about salts initially, and I want you to think about it. If you've got your tea and you're dissolving water in the tea, you'll get a lot more sugar in your tea if your tea is hot than you will if your tea is cold. So let's take a look at those factors that impact your solubility. Now you want to be careful here because we're going to divide this into those that affect the rate, the speed at which something will dissolve, and then the factors that will affect the amount of solute. So keep those separate. There is some overlap, but tricky multiple choice questions are going to make sure you understand that difference. Now, if we want to speed up the rate of dissolving, we can agitate. And if you remind me, I'll show you my fun magnetic stirrer that will agitate and stir. If you stir, you get more collisions between solute and solvent. And much later in the semester, the very last unit, you'll see that anything we do to increase collisions is going to increase the rate of a process. Now, if we expose more surface area, so if I'm dissolving my sugar in granulated sugar versus cubed, if I take the same amount of sugar in cubed formed as I have in granulated, the granulated will dissolve faster. Increase surface area, increase collision. You're exposing the solute to the solvent, allowing those attractions to form more effectively. And this is one of the areas of overlap. If you increase the temperature, you will also increase the rate at which it dissolves. More collision, increased rate. Now, let's keep that distinct from the amount that will dissolve per given amount of solvent. We're going to talk about 3 different ways to discuss this given amount of solvent. The first is pretty obvious. It is amount of solvent. So that's why when we reference solubility, we give it on that kind of normalized frame. All right, the more solvent you have, the more solute that will dissolve. Okay, but now most of our discussion is going to say, given that set amount of solvent, what will affect the amount? Well, temperature. I would say for most salts, there's a couple of exceptions. The solubility will increase with temperature. Now, we'll see a chart in a little bit that is an exception to this. But for most solutes, solid solutes, an increase in temperature will increase the solubility. Now, to make sweet tea, what they do is, and we'll see this word in a minute, they heat it up and heat it, and then they add the sugar. So they add as much sugar as possible. We call that saturating it. So they saturate it, and then what they'll do is they'll cool it. And they get a little bit more sugar dissolved that way, although it's not as stable. All right, gas solutes are just the opposite. Think about it. If you take your soda and you open it up and you put it outside in the sun, you're going to decrease the solubility for gases. Now, there's one other factor, but it only affects gases. Pressure does not affect liquids and solids very much. Pressure affects the solubility of gases in liquids. If you increase the pressure, the solubility also increases. Okay? So when you open your can of soda, you're actually decreasing the pressure. And when you decrease the pressure, you decrease the solubility of your CO2, and that carbonation comes out. Okay, now those are the factors that affect the rate and the amount. Now let's talk about that word saturation that I just introduced. There's 3 words that we use. Saturated. If something is saturated, it means full of. So when a substance is saturated, it has the maximum amount of solute that can be dissolved, okay, for a given amount of solvent at a given temperature. Saturation changes with temperature, so that's key here. We're talking about a given amount of solvent at a given specific temperature, and if it's a gas, we also have to specify the pressure. So that's the maximum it can hold. Now, you would know this. You would know if, say, your tea was saturated, because when I was a little girl, I would do this. I wanted to make sure I had all the sugar I could possibly get. So if you have some solid remaining at the bottom, so I always made sure I had a good 1/4 inch of sugar remaining at the bottom of my glass, because I knew if I had some solid remaining at the bottom that it was saturated, that no more would go into the solution. Unsaturated. I would know if my tea was unsaturated if when I was adding the solute, I could dissolve more. So if you have your solution and you add more solute and it all goes into still one big solution with no solid on the bottom, then you know that you have an unsaturated solution. Now, it's possible to make a solution that is supersaturated. They are not very stable. Supersaturated contains more, and you have to force the solute in by heating it up and then cooling it off very, very slowly. You can test that it's supersaturated because all it takes is one crystal. Sometimes all you have to do is kind of hit the solution or disturb the solution. So one crystal will disturb the solution and a whole bunch. So all of the excess, whole bunch is not very scientific, isn't it? All of that excess solute will precipitate, PPT for me is precipitate, out onto the bottom. And that's how you would know that you had those solutions. All right, and that's what these pictures are showing you here. Here, they're showing that it's unsaturated because as you wait over time, you started with 100 grams, 5 went into solution. We're at the same temperature. After a period of time, it all finally dissolved. Okay, now this is saturated, we know, because no matter how much time, we still had 9 grams left on the bottom. So as long as there was some solid on the bottom at that given temperature, then we know that it's saturated. Now, if we heat it, if we change the temperature and heat it, notice that all 100 grams went in, right? And it's likely unsaturated. We wouldn't know quite for sure until we added more solid to tell. If you add more solid and it dissolved, it would be unsaturated. If you added more solid and it went to the bottom and it stayed solid on the bottom, then we know it was saturated. Not sure how to say that. Hopefully you get that idea. Okay, then if we cool it slowly, notice that really the solution only wanted 91 grams at 25 degrees. And in this situation, we have 100 grams at 25 degrees. That represents supersaturated. It has more solute than it would normally want at 25 degrees. Now, all it would take is adding a single crystal to this or disturbing it somehow, and those 9 grams would precipitate out. Okay? And we would get back to a saturated state. All right, now there are curves that tell us how much will dissolve, and those are called solubility curves. Now I want you to pay close attention. You have a big one that I handed out with your homework. Remember, because the one did not print very well. So here I want you to pay close attention to what's on the y-axis. Notice that this is grams of solute per 100 grams of water. So I said that solubility is per amount of solvent. So in this case, these charts are showing per 100 grams of solvent. And this is showing the change in temperature. Now, these are all salts, and if you'll notice, they all increase solubility with temperature, with one exception in this chart. That doesn't mean, no, one exception of a salt, and then we're showing ammonia as well. This is the exception of the salt. That doesn't mean it's the only existing exception. That's the only one on this chart that decreases in solubility. Now, ammonia is much like a gas. So if you heat ammonia, you're going to smell it. You'll know that that gas is coming out of solution. And so ammonia also decreases with temperature. But other than that, the salts in this chart all increase solubility with increasing temperature. Now, let's contrast that to the solubility of gases. Notice that carbon dioxide, this is the solubility. This is in a unit we haven't talked about yet, milli, and this is a unit we haven't talked about, but it is per amount of solvent, so I'm just going to leave it at that. And you notice these all decrease solubility with increasing temperature. Okay? Now, when we're reading this chart, I want to point out a couple of points if we're looking at a given line. So let's take a look specifically at this potassium nitrate here. So if you are on the line, so any place on this line at any temperature and solute on this line, for example, right here at 40 degrees Celsius and 60 grams, I have a saturated solution is on the line. So let's just look at an example of 40 degrees Celsius to pick a point. So for this at 40 degrees Celsius, 60 grams of KNO3 would be able to dissolve in 100 grams of water. Okay. Now, if we were at any place for potassium nitrate, I'm just looking at the potassium nitrate now, any place below the line, so anywhere on this chart below the line is unsaturated. So this is defined for each salt, okay? So anything below 60, so 50 is unsaturated, 40 grams is unsaturated, 30 grams, 20 grams, and so forth. Anything below the line is considered to be unsaturated for that salt. Now, everything above the line for a particular salt is considered to be supersaturated. Notice I'm using a shorthand for saturated there. Okay, so that's going to be above the line. So for 40 degrees, 80 grams would be supersaturated, 90 grams and 100 would be supersaturated, 120 grams. Anything above 60 grams would be supersaturated at 40 degrees. Okay, we're going to look at using these solubility curves, and taking a look at some of the calculations with them. But let's just talk briefly about this. Most of the solids increase in solubility, the gases decrease in solubility. I'm going to start here in our next video. So until then, this is signing off.